It's always good when we start with fractions to throw out there this whole thing here. What are the names of the parts of a fraction? On top of a fraction, and again, we don't use these very often, but every now and then they come up here. Top part of a fraction is called the, Calvin,
Numerator?
did you say the numerator?
Yes.
You did say the numerator. Top number is the numerator, the bottom number is the,
First.
Peter, the denominator. IMG is denominator. And then the little fraction line, we pretty much lovingly call the fraction line. You know, the bottom number set tells you how many equal parts you cut something into. How many equal parts. The top number really tells you how many of those equal parts you have, what you're talking about. So if you have the ever popular pizza, you're cutting it into 8 pieces. Try to get them as equal as possible. You eat 7 of them. 1, 2, 3, 4, 5, 6, 7. That would be 7/8 of your pizza. Now that's kind of 5th and 6th grade stuff, so what we do talk about is this. Write down this example because we're talking about fractional parts of things. For example, there were 30 questions on the test. 1/3 were, there were 30 questions on the test. 1/3 of them were true/false, and the other 2/3 were multiple choice. Wait, I'm sorry. 1/3 were true, false, and 2/5 were multiple choice. I'm sorry. And 2/5 were multiple choice. Thought they were the same there, but they mixed it up on you. The question is, how many true, false questions were there? And how many multiple choice? How many true/false, and how many multiple choice? And you know what I'm going to tell you to do. Anybody? Lutz, what am I going to tell you to do? Draw a picture, or in this case, it's just a rectangle. You draw this little box. Eventually, I won't have you do this, but for right now. But for right now, we are. What does this box stand for? It stands for all 30 questions, right? If I'm looking for 1/3 of it, what's my next step? I need to cut that box into how many equal pieces? 3. No, we're doing this one first. 1, 2, 3. If I cut 30 into 3 equal pieces, Gary Ronning, that means each piece is what? My 30 cut into 3 equal pieces, each piece is 10. That means I'm talking about just 1/3 of it, so how many true, false questions were there? Yes, 10, because. Now, to find out how many multiple choice, you're going to have to draw a separate box because it's a whole separate fraction. That box still stands for 30 questions, but this time you're cutting it into 5 equal pieces. 1, 2, 3, 4, 5. If I take 30 and cut it into 5 equal pieces, Jacob, I get how many in each box?
6.
6. And if I'm looking at just 2 of them, 2 of the 6 pieces would give me a total of 12 multiple choice. Now, you probably could ask another question, how many questions are left that aren't multiple choice or true and false? If I have 30 questions on my test, 10 are true, false, 12 are multiple choice. Lutz, there are.
8.
And what do you think those are? Short answer? Fill in the blank? No, they didn't tell us. But you got 8 questions left over. Point is moot, I suppose, for the most part. And then last, they also will ask you something like this. Order from least to greatest. Least to greatest. I might actually give you a helpful little hint here. 3/6, 3/5, 3/8. 3/6, 3/5, 3/8. If you're looking at those, how do you know which is bigger, smaller, or none of the above? If you're asked to order those from least to greatest, what is the first thing you should think about if you're trying to compare? You have a sprinkler there. Kelsey?
Reduce.
Well, they already, okay, yeah, you want to reduce, and those are already reduced. Oh, they're not reduced. I stand corrected. Oh, sure, let's think about this as 1/2, sure, sorry. I got a little sidetracked there. Mental flaws. Grace?
Maybe think of which one is half, which one's greater than
Yeah.
half.
That's a good way. The first thing, there's harder ways to do it, but the first thing to think about is how do they compare to 1/2? And that might just help you out. For example, we know that 3/6 is 1/2. 3/5. If you ate 3/5 of a pizza, did you eat more than 1/2 or less than 1/2? Eli? More. So you know that 3/5 is bigger than 3/6. And then if you look at 3/8, if you ate 3/8 of a pizza, did you eat more or less than 1/2? Evan?
Less.
Less. So you know, if you're putting it in order, you know your 3/6 is exactly 1/2, 3/5 is a little more than 1/2, and 3/8 is less than 1/2. That should be your first one, just because that is a simpler way. There's other ways to do it. But what about this fraction? What if I had 2/3 compared to 3/5? 2/3 compared to 3/5. Both of those are bigger than 1/2, by the way, so you can't use that little methodology. Anybody? Which one's bigger and why? And you can't draw pictures because you're not accurate enough in your cutting. It'd take you way too long, and your pictures are nowhere near close and good enough to figure it out. So let's rule out picture drawing and comparing to halves. Ryan? You could look at your circles, but let's go away from that. Calvin?
The denominator. See which one is bigger.
So you're saying automatically 3/5 is going to be bigger than anything that has a denominator that's smaller than half? Christian?
2/3 is bigger
I know, but I'm asking why.
because 2/3 is like 1 away from 3 from 3/5 is 2.
From 3?
I wouldn't say.
Oh no,
Which one
Oh, maybe it is, I don't know.
Which one is closer?
Which one is, how do you know that though?
Because 2/3 is closer to 1.
Here's 1. 2/3 is right here. Here's 1, 3/5. 1, 2, 3, 4, 5. 3/5 is here. I don't know, is that right? Isn't that depending on how I draw my things? Let me just stop you there. If you're ever asked to compare two fractions, here's the beauty. Here is a shortcut that you can use. first of all, think about this, start at the bottom and multiply diagonally, which means this. Take 3, go across diagonally and multiply. 3 times 3 is 10. Start here, oh sorry, 9. Start here, multiply diagonally, 5 times 2 is 10. 2/3 is going to be bigger than 3/5. And the reason that works is really what you're doing is you're finding common denominators. Remember doing that last year? Really, the best way to do it is to do this. 2/3 and 3/5. What's their common denominator? Remember, what number does 3 and 5 go into? Both evenly go into 15. Remember doing this when we added fractions? 5 times 3 is 15, 3 times 3 is 9, 3 times 5 is 15, so 2 times 5 is 10. That's where these numbers 10 and 9 come from. 10/15 is bigger than 9/15, so 2/3 is bigger than 3/5. So rather than doing all this, a quick shortcut is just to go from the bottom, multiply diagonally, get, multiply bottom up. 10 is bigger than 9, so this one's going to be bigger. That was just a little side note there, by the way.